All right, let's jump right in. Welcome back to The Explainer. Today, we're doing a deep dive into an absolute masterclass in test automation, pulled straight from some fantastic source material. If you're an SDET, a QA lead, or honestly just someone obsessed with shipping flawless software, you are exactly where you need to be. We're going to break down two industry heavyweights, the page object model pattern combined with Playwright for the web and Appium for mobile execution. It's a lot of great stuff, so let's get to it. Here's our roadmap for this explainer. We'll start with the automation scaling challenge, move into web testing with POM, then we'll tackle mastering advanced mobile gestures, controlling environments with capabilities, and finally wrap up with the future of QA. Section 1. The automation scaling challenge. So think about this for a second. Are your automated tests constantly breaking under the weight of UI changes and complex user interactions? It's incredibly relatable, right? There is literally nothing more frustrating than logging on in the morning and seeing a sea of red failed tests. And it's not even because the app is actually broken. It's because someone changed a single CSS class name, and boom, your entire framework is on its knees. We've all been there. Because once you move beyond a handful of simple scripts, you inevitably hit a wall. Suddenly, you're managing these incredibly complex page object hierarchies. You're constantly fighting synchronization and timing issues, where tests try to click elements before they even fully render on the screen. Add in cross-browser quirks, adapting to relentless UI updates, trying to maintain consistency across a growing QA team, and pulling your hair out over advanced multi-touch mobile features, well, your framework's gonna collapse if it isn't structured properly. Bottom line, we need a massive automation upgrade. Moving on to Section 2, Web Testing with POM. So the page object model, or POM. You probably know it, but think of it as a design pattern that acts essentially like a blueprint for your application. Web pages, or even just components, are represented by class files that encapsulate UI elements and their functionalities. It's basically a protective bubble. It hides all those messy UI details, the locators, the XPaths, the CSS selectors, behind a clean, highly readable interface. Your actual test scripts shouldn't have to care how to find a login button, right? They should just tell the page object, hey, click the login button. And honestly, this distinction is a total lifesaver. Contrast this with the old way, spaghetti test scripts. If a dev changes the ID of a search bar, you're stuck manually updating 50 different hard-coded files. Total maintenance nightmare. But with POM encapsulated scripts, you have a single centralized location. You update that locator in exactly one page object class file, and instantly all 50 tests inherit the fix. It drastically cuts down on code duplication and makes your framework incredibly robust. So why pair POM with Playwright specifically? Well, Playwright is basically the perfect engine for the POM vehicle. It gives you a unified API across different browsers, which means your page objects remain completely consistent whether you're testing on Chrome, Firefox, or Safari. Plus, Playwright's built-in support for async operations just aligns flawlessly with POM, gracefully handling those annoying synchronization issues we talked about earlier. It can interact with literally every web element type out there, and it makes it super easy to spin up reusable, custom utility methods. All right, let's take this from theory into practice. Implementing POM in Playwright is a really logical progression. First, you set up your Node.js and Playwright project, and hey, you can even use Playwright's test generator to record your baseline tests to get started. Then comes the crucial step, creating a web page object to abstract those interactions into class files. Once those are built, you'll use those page objects in your actual test scripts, which suddenly become incredibly concise. You execute the test in headed or headless mode, and from then on, you simply maintain and expand those central object files as the UI inevitably evolves over time. Section 3, Mastering Advanced Mobile Gestures. I really love this quote from our source material. In today's mobile-first world, gestures and touch interactions are at the heart of delivering seamless user experiences. That really hits the nail on the head. You just can't validate a modern mobile app by only clicking simple buttons. Real users pinch, they zoom, they flick, they drag. To truly test an application, your automated framework absolutely must be able to seamlessly mimic real, complex human behavior. Thankfully, Appium, as a cross-platform framework, handles these interactions brilliantly using the WebDriver protocol and W3C Actions APIs. To test effectively, there are some essential touch gestures you need to master. You've got the tap for your basic single touch actions, swipe and scroll to navigate or browse around, drag and drop for moving items to specific locations. Then there's pinch and zoom, which is a complex multi-touch action that requires precise coordinate mapping. And of course, the long press and double tap. With Appium, you can programmatically emulate the whole shebang dynamically across both iOS and Android. Let's ground this in a real-world scenario, like testing a food delivery app. Think about it. You need a swipe gesture to casually browse horizontally through restaurant categories. You need drag and drop to test cart management. A multi-touch pinch to zoom is essential so users can inspect those high-res meal images. You'll definitely need a pull to refresh to validate real-time order updates from the server, and a long press to reveal hidden menu options. If your Appium framework can't execute these flawlessly, you're not actually validating the user experience. All right, Section 4, Controlling Environments with Capabilities. Now, in the Appium 2.0 world, the old desired capabilities have evolved. We now use specialized options classes, which are encoded in JSON format. These act as your ultimate control panel. Think of yourself as the director on a movie set, dictating exactly how everything should run. These classes are sent to the Appium server right when a session is requested, letting you configure server settings, operating systems, emulators, and the precise rules for how the app should behave when the test starts. There are dozens of capabilities you could tweak, but our sources highlight a specific set that are absolute game changers for speed and stability. You've got the general ones like platform name and automation name, but check out the Android specifics. App wait activity is incredible. It forces Appium to wait until a specific UI activity is actually in focus before starting the test, which kills those early sync flakes. Disable Android watchers is another great one. It saves valuable CPU cycles by turning off background loops if you don't need to verify toast messages. And on the iOS side, use pre-built WDA skips the WebDriver agent build time to drastically speed up startup, while use JSON source gives you lightning-fast conversion of the app hierarchy for massive apps. These aren't just minor settings, they are massive performance multipliers. Which brings us to this reset strategies matrix. This is absolutely vital. You know as well as I do that most of your execution time in mobile automation is burned just installing the application. Now, if you set no reset to true and full reset to false, Appium doesn't stop the app, doesn't clear the data, and doesn't uninstall the APK between tests. It just keeps on running. On the flip side, if you need a pristine, virgin state for a test, setting full reset to true will stop the app, clear the cache, and completely uninstall the APK afterward. Mastering how you manage this application state between your test cases is going to save you massive amounts of execution time in your CI/CD pipeline. And finally, Section 5, the future of QA. Take a look at this insight from our sources. The future trend of the page object model pattern is the development of page items automated with AI. It's pretty wild, right? Even the most advanced structured architectural patterns we've discussed today are actively evolving. We're no longer just talking about writing scripts faster. We are talking about fundamentally changing who or what is actually writing them. So what does this next-gen QA evolution actually look like? Well, we're moving toward AI algorithms that can automatically generate your page object models for you. Imagine AI analyzing front-end UI changes and instantly recommending or applying updates to your test scripts. We're already seeing independent AI agents taking over routine test design. Integrations like Claude Code combined with Playwright's Model Context Protocol, or MCP, are creating autonomous orchestration systems. But don't worry, these tools aren't here to replace testers. They are here to amplify SDET productivity, freeing you up to focus on the tricky edge cases, security, and complex logic, while the AI handles the boring routine maintenance. Which leaves us with one final, pretty provocative question to ponder. Is your test framework actually ready for tomorrow's apps? If you're still relying on brittle spaghetti code and constantly battling mobile device states, it is definitely time to start implementing these automation upgrades today. Get your page object models structured cleanly in Playwright, dial in your Appium capabilities, and prep your framework for this AI-driven future. Thanks so much for joining me for this explainer, and I'll catch you in the next one. Happy testing!